Welcome everyone to chapter 10.1, areas of parallelograms and triangles. So in this chapter we're starting area and we're going to start off with some of the fundamentals, beginning with the rectangle. So the rectangle is a shape with all right angles. Okay, and so you've probably seen this formula before for the area, which is length times width. A lot of people think the length needs to be the longest side, but it does not. It just needs to be one of the perpendicular sides. So the length and width need to be perpendicular to each other, and we multiply those to find our area. Okay, very similar to the rectangle is the parallelogram. The parallelogram, think of it as a kind of a rectangle that's been stepped on and it slides over due to the pressure. So the formula is going to be very similar. Okay, so it's going to be the two dimensions multiplied by each other, but now we're not going to be using the length or the width. We're going to call them different things. We're still going to use this part of the rectangle, but we're going to call it the base now instead of the length. Okay, so we're going to call that the base. And it's very important you use a little b because a big B means something else. Okay, that means the area in terms of when we're talking about surface area, we're going to be using big B. So don't use a big B, use a little b. Now we need this length called the height also. Okay, because notice in the rectangle we multiplied the width and we multiplied the length times each other, and they were perpendicular. It's very important to recognize that it was perpendicular, so we need that same perpendicular relationship between these two dimensions. So it is the base times the height, where the height is perpendicular. Don't forget that, okay? And lastly, we have the triangle. Now this particular video is not about proving why the formulas work, but we can still go over the basics. Wow, I missed horribly. Let's try this again. Okay, so if we have a triangle, we can draw a triangle composing half of a rectangle. Okay, so if we draw a diagonal across a rectangle, it forms a triangle, and that is half a rectangle, and you would expect it to cover half the area. So if we're covering half the area of the rectangle, we just need to use our formula for a rectangle and divide by 2. Or the same thing as dividing by 2 is multiplying by 1/2. We're going to be using the base and the height. We don't call it length and width for the triangle. Some people like saying it like this, but it's the same thing. Multiplying by 1/2, dividing by 2, same deal. It's very important to recognize where is the base and the height. If we call this side our base, then the height needs to be perpendicular to that. So that would be our height. In other terms, the height is equal to the altitude. Remember, an altitude connects a vertex, which is here, perpendicular to the other side. So if your other side is the base that you're referring to, then you're golden, that's your height, and we can call that your height. But really, we can use any of these sides of the rectangle as our base as long as we have a perpendicular side, or a perpendicular line connecting the vertex to that side, okay? Now let's go ahead and apply some of these formulas. The first one, it looks like we have a parallelogram here. We don't know the measure of this angle, but based on appearances, we can assume it's not 90. So we're going to go ahead and assume that, oh, it even tells us it's a parallelogram. Okay, so we're asked to find the area of the parallelogram. What do we need? We need a base. We first write down the formula. We need a base and we need a height. Well, we're given that this is 90 degrees, so chances are we're going to use this for our height. The problem is we don't know it. Okay, we only need one unknown, and right now the area is the unknown, so we need to figure out what the base and the height are. Okay, so this is going to be our height. I'm going to change this a little bit so it's a little bit neater. Okay, now we can easily find our base. We're given two segments, so we can put them together to find our base, which is 20. 13 plus 7 is 20. Okay, so now we need to figure out our height. If you see here, we have a triangle drawn here. Let me redraw this. We have a triangle, and it's a right triangle because it's got a 90-degree angle. We could figure out the height by saying that 25 squared, the hypotenuse, is equal to the height squared plus 7 squared. Or we could recognize that this is one of our automatic Pythagorean triples. So 7, 24, 25 triangles. So this is actually 24. If you want, you can do the math, figure that out. I like to save time. So I memorized my triples. Now we're ready to input this into our area formula. So area equals the base, which is 20, pardon me, times the height, which is 24. I can easily do this in my head, and I encourage you to try this as well. Well, we're going to take off the 0. Imagine that it's 2 times 24. 2 times 24 is 48. There's an extra 0 with the 20, so we're going to add that on to 48 to come up with 480. Don't forget the units. Units squared. It's a measurement of area, so we need to square those units. Okay? That's example 1. Example 2 looks like we have a parallelogram again, and we do. The area of the parallelogram is 120 units squared. Find x and y. This time we're given the area, and now we need to find the base and the height. So we know, let's plug in our knowns, which is 120 is our area. We don't know our base. I'm assuming base as the lateral. And the height is 15, so we do know our height. So we can divide both sides by 15 to find our base. So we do 120 divided by 15. Let me write this out here a second. Divided by 15. 20 divided by 15. Oh, I already wrote that down. And we get 8 equals our base. So x equals 8. So we found x. Now we need to find y. Okay? So how do we find y? Well, y is this distance here. And if that's y, then this is also y over here. Notice how we have what appears to be a right triangle going on here. Okay, so what we need to do is we need to figure out this small distance right here. Well, if we know that this distance, x is 8, and this whole distance is 16, then we should be able to figure out that smaller distance by doing 16 minus 8, which is 8. So that's equidistant. These two distances are the same. Now we have 8, 15, and we have a missing side there. So if we wanted to, we could go 8 squared plus our 15 squared and solve for our missing y squared. Or we could recognize that we have another Pythagorean triple, which is an 8, 15, 17 triangle. So y is 17. One more area example, and then we're done for the day. We have to find the area of this triangle. So it probably would be helpful if we wrote down the formula first. Area equals 1/2 the base times the height. Now, what do we have? Well, our height given by our drawing is here. We don't know it. So strike 1. And then here's our base because it's perpendicular to the height. Okay, so the base and the height always need to be perpendicular to each other. So this is our base, and we don't know that either, so that's strike 2. But we're not going to have a third strike because we are going to figure out both of those values soon. Now, because we have a right triangle, as you can see here, where 13 is the hypotenuse, opposite the 90 degree, we can easily find h. How do we do that? Well, we can say 13 squared equals 5 squared plus our missing side, 8 squared. Or, I hope you guys guessed it, this is another automatic triangle. This is a 5, 12, 13 triangle. So this is actually 12. You can go ahead and solve it if you don't believe me, but you're going to get 169 minus 25 equals 8 squared, and that's 144. 144 square root, 12. So height is 12. Now we have another right triangle here. So this is our other triangle with that's a 90-degree angle, where 24 is our hypotenuse, 12 is our height, so that is the short side. Now, I hope you guys realize that, again, you could use Pythagorean theorem to solve for the missing side right here. We'll call this side A this time. I don't want to call it B because B is our big side, so we'll call this side A. So we have this missing side A that goes from here to here. I hope you guys know that you can use Pythagorean theorem, 24 squared equals a squared plus our 12 squared. Or you can recognize that the hypotenuse and its short side have a special relationship. So notice how the hypotenuse is double the short side. Well, that makes this a 30, 60, 90 triangle. So with a 30, 60, 90 triangle, if my short side is, let's call it x, that makes my hypotenuse 2x, double it, which is the case here, and that makes my medium side x radical 3. So I just need to take 12 and I need to multiply it by radical 3 to find a. Let me erase this. In this case, it is 12 radical 3. So now my base, if I'm going to leave it in radical terms, is simply the sum of 5 and 12 radical 3. 5 plus 12 radical 3. So now I have my base, I have my height, and I am ready to input it into my area formula. Let me go ahead and do that. Area equals 1/2 times 12 times 12 radical 3. Let me put this in parentheses because I have an addition sign here, and they are not like terms. Oops, I accidentally put 1 over 12 instead of 1 over 2. There we go. 1 over 2. Okay, so the first thing, I got a lot going on here. The first thing I'm going to do is I'm going to combine this multiplication out in front. I know you are responsible for distributing, but we can distribute after we multiply these two numbers. That's okay. That's within the rules. So we get area equals, I changed to blue, 6 times 12 radical 3 plus 5. Okay, now I need to distribute. So I'm going to distribute with purple. Sorry, that one didn't reach the 5. Okay, so once I distribute, I get 12 times 6 is 72, radical 3, plus 6 times 5 is 30, and I need the units squared. You can leave it like this. I know it probably makes it uncomfortable for some of you, but you can leave it like that. You may get a decimal, but you can leave it in radical terms. That's what I do with most of my classes, so be prepared for that. And see you next time when we talk about the area of trapezoids, rhombuses, and chi.